Dear friends, today we'll discuss some important, not only important, very important questions of lines of force, electric field lines or lines of force, then electric field, then about torque on the dipole. So let's start first. These are the questions, these are the 8 concepts on which we'll discuss the questions. Let's come to the first question. This is one important question. This came in 2015 board examination. This question I had already asked you in the previous video. I am just giving the solution here. Plus Q charge is sitting on a metal plate. This is a metal plate. This plate is a metal plate. Plus Q charge is sitting in close vicinity of a metal plate. Draw electric field lines. You can note the question. Plus Q charge is placed in the close vicinity of a metal plate. Draw electric field lines. This is a very important question. So now let's see how I will draw. This is plus Q. You know, if plus Q charge is there and metal is here, metal is placed close to it means immediately which concept comes here? What will happen? Induction. Metal is there means and one charge is very close to it, must in the metal induction happens. You know, the charges get separated. So the nearer end of plus Q, the near surface of plus Q, which charges develop there? Minus charge. Free electrons will move to that side and the other end effectively become plus charge. Is it clear now? So induction happens. Always remember, metal means induction happens. So now we'll draw the lines of forces. This is plus Q. From plus, lines come like this. Then the line come like this. Then the lines come like this. These are the lines of forces. Now the question may come, why I am drawing the lines of forces like this and touching the metal surface at how much angle you see? 90 degree. I had told you in property of lines of force that lines of force meet the surface of conductor at 90 degree. Why? The reason I will tell you in the next chapter. Okay. So now just to remember. So from this plus, again lines of force will go away. From this plus, from the plus, lines of forces will go away. If you want also you can draw one line or some line here like this, no problem. So this is the answer of this important question. But from that question we can discuss another one based on that concept. Suppose this question is still now not in the board examination, but I am discussing in the next question. We will start another question from that one. We will produce one question from that one. Suppose this metal plate is connected to earth. If the metal plate is connected to earth, then what happens? You know, these electrons come from earth through the wire and they neutralize the positive part. The positive part they will neutralize. So what will happen? No positive charge will be here. So this part will erase. So now the answer will modify like this. If metal plate is connected to earth, then you will modify the answer like this. Understand? First I just keep the metal plate very close to the plus Q charge. In the second question I connect the metal plate to earth. Okay. So now we go to the next question. Question number 2. Question number 2, now you see concept number 2 here. This is also a metal plate. This question came in 2016 CBSE sample paper. It's also one important question, but till now not come in board examination, but may come in future. One Q charge, plus Q charge also this one. Plus Q charge is placed on half of the radius. Half of the radius. This is R by 2. Total R, this is R by 2. From the center at a distance of r by 2 plus q charge is placed. Draw the electric field lines. How will draw the electric field lines? I again reminding you, charge is placed very close, metal is there, means which process happens? Induction. So this plus q will induce which charge? Minus charge in the inner side of the metal sphere. Inner side of the metal sphere. Then and the outer side of the metal sphere will be which charge? Positive charge. Okay, now induction part is over. We will draw the lines of forces. You see, from plus q how the lines of forces will pass? From plus q plus lines of forces start from positive and end at negative. So we will pass like this. This is one. And to this side also it will go like this. Then the lines of forces now goes like this. Now the lines of forces goes like this, But how I am drawing the lines of forces? How will know it will go like this? Now you see, you have to make the curve in such a way that the curve should meet the metal sphere at 90-degree angle. You have to make the curve such that it meet the metal at how much angle? 90-degree angle. How will you know it is 90 degree? It will meet at 90 degree or not? If you extend it in the backward direction, you see it must passes through the center. When it meet the metal, when you extend it, it must passes through the center. Then it is confirmed it meet at 90 degree. Because the radius or any line passes through center is perpendicular to sphere. You know that in geometry. Any line passes through center is perpendicular to sphere. So as metal it has to be perpendicular. So you have to draw the lines like this. You see, I am drawing the line here. You see, if I extend it in the backward direction, it must passes through center. See here. So you have to draw the lines like that. Then they meet again from the other end, they will emerge. But when they emerge, it seems as if they are coming from the center of the sphere. See, as if they are coming from the center of the sphere. It should be like that. As if they are coming from the center of the sphere. Okay, and this one. Here, this one. So this is the second question. 2016 CBSE sample paper question. Now we come to neutral point concept. Is a very important concept. Let us discuss about neutral points. What is neutral point? I am telling the definition of it. Neutral point is a point in an electric field at which point if we place any other charge, it experiences no force. The point is inside the electric field. Suppose one electric field exists here on this whiteboard, you see electric field exists here, but it is a point called as a neutral point. That means if a third charge, if any other charge are placed here, this charge when placed at this point will not experience any force. Though it is electric field, but at this point it experiences no force. It is called as neutral point. Neutral point is not any new concept for you. You know this in class 11th. You find I think in 11th the neutral point between sun and earth. At a point where no force of the force of sun, the force of earth cancel each other. When the body is there, then it experiences no force. Neither sun nor earth, no one apply the force, means actually their forces cancel there. So what is now neutral point? You come here. What type of questions will come from the neutral point? Question will come like this. Two charges plus Q1 plus Q2. Two charges are there. Question will come. Charge magnitude will give. Where should we place a third charge so that it experiences no force? Question will come like this. Two charges are separated by this distance. Suppose let us take the distance as d. All these common numerical values. Where should we place a third charge so that it experiences no force? Okay, so third charge will place it experiences no force, means indirectly it is telling to find which point? Neutral point. So it want to find neutral point. So neutral point, the point will be where? When these two are like charges. Two cases comes here. Let us discuss first for like. When these two charges are like charges, then what? Which side neutral point lie? Neutral point means electric field of this and electric field intensity of this must cancel each other. Means both electric field will be equal in magnitude and opposite in direction. Let us come to the point opposite in direction first. If I take the point here, this plus q electric field will be in which direction? Minus I because away. If now at this point, plus q to electric field will be where? Plus q to electric field also will be away. Q1 electric field away, q2 electric field away, both are in same direction. Is there any chance of cancelling? No chance of cancellation. So neutral point cannot lie here. If I take the point here, also plus q electric field will be this side away, plus q2 electric field also will be this side away. So there is no chance of cancellation. Neutral point will be somewhere here. The neutral point lie. Somewhere here the neutral point lie. Okay. So now let us see how. Because how here for plus q electric field will be this side E1 for plus q1. For plus q2 electric field will be this side q2 E2 electric field. Both are in opposite direction. Only they will have same magnitude. Then they cancel each other. Now see same magnitude E1 is equal to E2. Suppose let us take this point as x. So k q by x square. K q1 by x square. Electric field of q1. K q2 by x minus d square. Clear? So k cancel. I just put the expression of electric field due to point charge kq by x square. So q1 by x square, q2 by x minus d square. One thing just I want to tell you here, while doing this type of numerical, always try to don't do square. Always try to take the root over of both sides after this. If you take the root over of both sides, then calculation will be little easy. Means the next step will be root q1 by x, root q2 by x minus d. If you do it square, then it will be quadratic equation. It will be difficult to solve you. Better you just remove the square and make the root over of both sides. But another thing I want to tell you here, if q1 greater than q2, q1 magnitude is greater than q2 magnitude, then must be x greater than x minus d. X must be greater than x minus d here. You see, if q1 greater than q2, then x q1 greater than q2. If numerator is greater, then denominator has to be greater. Otherwise, how the ratio will be same? Then x greater than x minus d. I am just telling you, if q1 is greater, then x is greater. X is greater. If see here, this one I am showing. q1 is greater means x is greater means neutral point will be away. Neutral point will be little far away from q1 and close to q2. So what you understand from this? Now try to listen clearly properly. So if q1 is greater, then x is greater. X is greater, if q1 is greater, x is greater. Means neutral point will be at more distance from q1 and close to q2. So that means you understand neutral point will be close to less magnitude charge. Remember this line is very important. If two charges are like, neutral point lie in between them. If two charges are like, and lies close to less magnitude charge. Now understand this one. Okay, now we'll go to if they are unlike charge. Now let us see what will happen. Let us come to unlike charge. Suppose this is plus q1, this is minus q2. So if I take a point here as neutral point, what will happen? Plus q1 give the electric field to this side away. Minus q2 electric field will be towards. Is there any chance of cancellation? No, because they are in same direction. So neutral point lies either at this side or at this side. Because at this side you see plus q1 away, minus q2 this towards. Chance of cancellation. Here plus q1 away, minus q2 towards. Chance of cancellation. So that means neutral point will lie either at this side or at this side or at both sides. Okay, neutral point lie either side, either this side or this side, not in both. Direction may be opposite, but in both sides magnitude is never same. Magnitude will not be same in both sides. Directions are opposite, it is right. The neutral point will lie either this side or this side, not in both sides. Let us see. And which side neutral point will lie? Let us check. Suppose I am taking the point here. I am taking the neutral point here, which is at a distance. This distance you take D, and neutral point is at here, which is at a distance from Q2 at a distance x. I am taking the neutral point. I am assuming the neutral point at a distance x from Q2. So electric field of plus Q is to this side away, E1 vector, minus Q towards this is E2, and when U1 is equal to E2, then neutral point comes. So K Q1 by, for Q1 I am applying KQ by square. So what is the distance? D plus x square. D plus x square. For E2, K Q2, what is the distance? X. X square. Now see Q1 by D plus x square, Q2 by x square. What you see here? So D plus x must be greater than x. You can't deny. D plus x must be greater than x. If D plus x is greater, denominator is greater, numerator also will be greater. That means Q1 greater than Q2. So now is it clear? Neutral point lie at which side? At here Q2, that and Q2 is less. Means again, neutral point, if two charges are unlike, neutral point lies at the side, not in between them, but at the side of which charge? Less magnitude charge. Neutral point lie at the side of less magnitude charge. This also can come as a question. Prove that if two charges are unlike, neutral point lie at the side of less magnitude charge. It can be a theoretical question. You have to do this much and you have to show this one. Neutral point you have taken at Q2, near Q2, and Q2 is less than Q1. Neutral point lie at the side of less magnitude charge. Now let us see. So this is the about the neutral points. So you can solve if questions will come in exam. But one example I am giving you here. One example I am giving you. Suppose minus 4 microcoulomb charge this is, and one is I will take plus 2 microcoulomb. So at which side now neutral point will lie? Is it in between? No, because they are unlike. Is it at plus 2 coulomb or minus 4 coulomb? So you have to see, remember, magnitude I told you, magnitude less. Don't consider the sign. If you consider the sign, then minus 4 is less than plus 2. But in charge, plus minus sign has no meaning here. So you have to take less magnitude, means neutral point will be at this side. You have to take neutral point. This side, plus 2 microcoulomb side. Let us take this as x. This distance must be given in the question paper. It will give this distance. Then just equalize their intensity. And don't do square. I am again repeating you. Just do the square root. Don't do square. If you do square, you will get quadratic equation which will be difficult to solve. So these are the questions based on neutral point. Now you can able to do the questions of neutral points. Now we will come to the next Millikan oil drop experiment question. This is your NCERT book additional exercise first question, question 25. It's a very important question. Millikan oil drop. Millikan, scientist Millikan has done this experiment to find charge to mass ratio of electron. You know, J.J. Thomson discovered electron, but who find the charge to mass ratio of electron? Millikan. First charge to mass ratio was found at that time. After that we got charge, but first charge to mass ratio Millikan got. But how Millikan got? Very simple experiment Millikan did actually at that time. One oil drop. Millikan took an oil drop freely suspended. You see, one oil drop is freely suspended. Oil drop is freely suspended. Is it possible? Can I keep this marker free like this? If I keep freely, what will happen? It is falling in downward direction. Why it is falling in downward direction? Okay, because of its weight. Weight act, you know, in 11th class in downward direction, for which this body is falling. This oil drop also weight act in downward direction. So oil drop will fall downward. But how this oil drop will exist at this point? Is it possible? But Millikan has done. How Millikan did this actually? Millikan has taken one charged oil drop. Of how much charge? Q. Some lack of electron or some excess of electron, but this oil drop is a charged oil drop, and you keep the oil drop in an electric field. If you keep a charge Q in electric field of intensity E, how much force acts on the oil drop? How much force acts on the charge? Already I have told you, F is equal to QE. F is equal to QE. And if Q positive, force is along the field. If Q negative, force is opposite to field. So here, must force act in this direction to cancel mg. Otherwise, suspension is not possible. Free suspension is not possible. If force act in this direction, charge is positive, then electric field also will be in that direction. If charge is negative, electric field will be in downward direction, because for negative charge, force and electric field are in opposite direction. Okay, now you forget about electric field, but in some question, electric field direction will act. If charge is positive, electric field will be along the force, means upward. If charge is negative, electric field will be opposite to force, means downward. Now F is equal to QE. So now F is equal to mg here, are neutralized. So F is equal to mg. But what is F? QE. QE is equal to mg. So this is the basic formula to solve any question of Millikan oil drop experiment. Remember, mg downward, QE upward. So mg is equal to QE. But accordingly, then what question will asked here, you can able to solve. But in NCERT book, it is asked to find a radius of the drop. Drop is spherical, to find a radius, then you can do easily QE. Then you have to convert the mass. You know density is equal to mass by volume. So mass is equal to density into volume. Then density must be given in the question. Then what is the volume expression? 4 by 3 pi r cube. Then in NCERT book, it is asked to find the radius of the drop. You can put all the quantities. This is G, this one is G, this one is G. Okay. Then you can put G according to the question paper. Then rho must be given, E must be given, Q must be given. Then you can able to find R. If in this question suppose mass is given, charge is given, G will give in the question paper. Suppose electric field is asked, you can find electric field. You can also find direction. I already told you. Okay. So this is the different questions can generate from this concept of Millikan oil drop experiment. You can make 4 or 5 questions from that. But any question may come in the exam. If you understand the concept, you can able to easily attend the Millikan oil drop question. Then come to dipole moment. This is one important question. Never come in the previous years. But suppose this is minus 2q, this is plus q, minus q, this is minus 2q plus q plus q. Find the dipole moment of the system. This is D, this is D, this is D. How will find dipole moment of the system? If I recall you, so it is nothing but water molecule. HO, H2O. So this is water molecule like structure. How will find the dipole moment of this system? But here it is not exactly water molecule because these sides are same. but like water molecule it is. Like, but not exactly equal to water molecule. So what happened here? Now see. So how will find the dipole moment? Plus Q, the equivalent. I have told you center of the plus 2Q lie here at the middle. So now this dipole converts into minus 2Q plus 2Q. This is the separation. And this is D, and what is this now? This is nothing but the median. And median, you know how to find the median distance. This is hypotenuse square D square, and this is D by 2. So this is D by 2 square, then minus using Pythagoras theorem. Then D square, then this is D square by 4, then 3D square by 4. It is coming root 3 D by 2. So what is the dipole moment of the system now? Net dipole moment is 2Q into distance. Magnitude of either sides into distance. Distance is root 3 D by 2. So it is coming root 3 Q D. Is it now clear? So now you say again I am repeating you. I just took the center of plus 2, this is plus 2Q, then this is the dipole, plus minus 2Q, plus 2Q, and separation. And separation is how much? Root 3D by 2, because this is median. I just found what is the median expression. Already you know this expression. Sometimes some students mark up this one. Median expression this is. So now coming to root 3QD. Magnitude of either sides into distance of separation. Okay, now we will go to the next question. The top question, 27 number question of an NCERT book. I have told you to do this question. This is also one important question of an NCERT book. 27 number question. So what is this question? This question is like this. You can see your NCERT book. Question is there. Electric field exists in the Z direction. I am taking this is the electric field. But direction is constant. But magnitude of electric is not constant. Magnitude gradually increasing along positive Z direction. Which rate? 10 to the power 5 Newton per Coulomb. Newton per Coulomb. It is increasing in the positive Z direction. 10 to the power 5 Newton per Coulomb per meter. So that means I can write del E by del Z. Or also you can write dE by dZ. How electric field change with respect to Z? 10 to the power 5 Newton per Coulomb. It is given in the question paper. You can read, you can understand the question. And dipole, one dipole of a dipole moment, 10 to the power minus 7, dipole moment, Coulomb into meter, dipole moment, that also exists in the Z direction, but dipole moment is along negative Z direction. Means dipole is here, dipole moment is negative Z direction. Means here is minus Q, here is plus Q. Because dipole moment is in this direction. Dipole moment is given to you 10 to the power minus 7 Coulomb into meter. Question is asked here to find force and torque on the dipole. First let us see torque. Torque very easily. Now you know torque. What is the torque formula? PE sin theta. So sin theta, theta is how much? Electric field is along positive Z direction, dipole moment negative Z direction, theta is 180 degree. What is the value of torque? Torque is 0. Now the dipole and the dipole torque is 0. Sin 180 is 0. But let us find the force. How much force act here? Let us see. Now force on plus Q will be his direction, plus Q will be in this direction. F1. Because force on plus Q will be along the field. This is the field direction, electric field direction. Okay. Force on minus Q will be in which direction? This direction. F2. Force on minus 2. Now can you tell me which force will be more? F1 or F2? Which force will be more? You know, charges are same, but electric field is not same. The forces obviously will be different. But which one is more? Force where electric field is more? Electric field is increasing in this direction. Electric field is increasing positive Z direction. What is the electric field here? The electric field is more at minus Q. And electric field is more at minus Q here because it is increasing in this direction. As minus Q electric field is more, so F2 is more. means F2 is more means the net force will be in negative z direction, and the net force will be F2 minus F1, and the direction will be negative z direction, means minus k cap. I got the direction of the electric field. Got the direction of the net force, because here electric field will be more, so force will be more because charges are same. Now you see, this is Q E2, this is Q E1 minus k cap direction. This is Q taken common, E2 minus E1, E2 minus E1. Let us do, this is daily change in electric field from this to this. Now do one thing, divide by del z and make into del z. I read, suppose this to this distance is del z I am taking, so divide by del z into del z. Q into del z is what? Either charge into distance of separation is dipole moment into del E by del z. So you have the dipole moment 10 to the power minus 7, it is given here. You have del E by del z 10 to the power 5, you are getting 10 to the power minus 2. So this is the answer, this much Newton along negative z direction minus k cap. This is the force act on the dipole. It's a very important question. It can be 3 marks shots. Till now it is not in the board examination, but it may come in the next year or for you. So try to practice it more. I hope you understand this one. We will go to question number 7. Question number 7. This question came in 2011 in Delhi board. When the question was different for Delhi board and for the other all India. Okay, so in Delhi board this question came. In Delhi CBSE board this question came. But again this question came this year in All India board 2020. This question came. 2011 Delhi board question now become the All India 2020 question. Now see, it's a very good question. I am drawing the figure now, all of you see. So this is the x-axis, this is x dash, this is y and the y dash, plus q charge is here, minus q charge is here, another dipole is here, this is minus q charge and this is plus q charge. This angle is given 180 degree. Question asked like this, to find the net dipole moment, as well as question asks if electric field exists along x-axis. In x-axis there is electric field E exists, then find the torque, net torque on the dipole moment. Find the torque and find the net dipole moment. Net torque and net dipole moment. Firstly, let us find net dipole moment. You see, one dipole is this one, minus q to plus q. It exists in this direction. Is it clear? This dipole moment is given P. It is given in the question. P is the dipole moment of each dipole. And this dipole moment is in this direction, minus q to plus q. This is also P. Dipole moment. What is the angle between P and P? 120 degree. So what will be the net dipole moment? You will use your triangular or parallelogram law formula. You use your parallelogram law formula. You use the net dipole moment is P square plus P square plus 2pp cos 120 degree root over, and you will get your answer also P. If you see, if you solve, you will get your answer P. Means net dipole moment is also P. But where is the direction? This is the magnitude. But where is the direction? This is P, this is P, 120 degree angle. According to parallelogram law, it must now go in the middle here. This is the net dipole moment P. This is the net. And it bisect that 120 because just at the middle it will go. 120 means this angle will be 60. If this angle is 60, because it bisect 120, now this angle will be almost 30 degree. This is 90 degree x-axis and y-axis angle, so this will be 30 degree. So I can write the direction. Direction is 30 degree with positive x-axis. 30 degree with positive x-axis. This is the direction of the dipole moment. Now I have already told torque. What is the torque here? P is sin theta. So P E sin angle is 30 degree already we know. Sin 30. Then PE by 2. This is one important 3 marks of ours which comes this year in 2020 board examination. Okay, so now this is the dipole moment and this is the torque. Net dipole moment, net torque, and you have to mention the direction clearly, otherwise you will lose mark for the direction. Let's come to the last question. Q1, Q2. Two charges are there. Q1, Q2 plus Q1 plus Q2, but their magnitudes are not same. Draw electric lines of force. Question will come like this. Draw electric lines of force. They are positive, but you know I have already shown you plus Q. Then what happened to the lines of forces? Lines of forces are like this. I am again reminding you, like this lines of forces. No lines of force will be at the middle because test charge will not move neither to this side nor to this side because both apply force opposite to each other. Also I can tell you now, neutral point lie at the middle. So no lines of forces will be at the neutral point because no force there. Okay, so I have told you through the other lines of forces like this, it will go in this way so that it will not pass through this charge, this point. But if the magnitude will be different, and in question it will give Q1 greater than Q2. If Q1 greater than Q2, then it is just testing you whether you know the position of neutral point or not. Now already I have told you everything about neutral point. So where it will place? Neutral point will be at the side of less magnitude charge. So neutral point will be here at the side of less magnitude charge. You will write the neutral point and now you will draw the lines of force like this. Lines of forces will be like this. These are the lines of forces. Now more lines of forces will start from plus Q1. More lines of forces will start from plus Q1. Less lines of forces will start from plus Q2. Because lines of forces, how many lines of forces will start from a charge? That is proportional to the magnitude of the charge. Remember this point. How many lines of forces linked with a charge? That is proportional to magnitude of the charge. As Q1 magnitude is more, so more lines of forces will be linked with the Q1 and less will be linked with Q2. Okay, today I discuss the important questions, 8 important concepts and so many questions basing from this we discussed today. Thank you.